Hello everyone, welcome back to my channel. Today we will be starting with the next topic of our chapter ellipse, which is the standard forms of ellipse. So first is the x square by a square plus y square by b square is equal to 1. This is known as a horizontal ellipse because the value of a is greater than b, and where we can say b square is equal to a square in bracket 1 minus e square. From this diagram we can see that the center is at origin, so it will be 0 comma 0. The foci, there are two focuses in ellipse, which is s and s dash. First is a comma 0 and the second is minus a comma 0. The directrix here are x is equal to plus a by e and x is equal to minus a by e. Here it is plus a by e and here it is minus a by e. The equation of major axis is y is equal to 0, it means the x-axis. In case of a horizontal ellipse, we know that the x-axis is y is equal to 0 and this axis is called as a major axis. Similarly, for x is equal to 0 y-axis, we say that this is the minor axis. The equation are done. So now the ends of the major segment, which are a and a dash, are a comma 0 and minus a comma 0. The length of the major segment a dash will be 2a. The distance of ss dash, which is the distance between the foci, is 2ae. The ends of the minor axis will be b and b dash, 0 comma b and 0 comma minus b. The length of minor segment will be b dash, which is 2b, and the length of lattice spectrum will be 2b square by a. The eccentricity e will be under root 1 minus b square by a square. These are all the formulas, or you can say equations, important points we should consider while learning. Don't forget this point, remember this well. The second type of ellipse is the vertical ellipse. Equation is same, x square by a square plus y square by b square is equal to 1. But a is less than b and a square is equal to b square 1 minus e square. Here this is an ellipse, so the center is at origin, so it will be 0 comma 0. The foci s and s dash are here and here, so it will be 0 comma be and 0 comma minus be. The directrix will be y is equal to plus b by e and y is equal to minus b by e. The equation of my major axis is x is equal to 0, which is the y-axis, this one, and the equation of minor axis is y is equal to 0, which is the x-axis, this. Ends of the major segment will be b 0 comma b and b dash 0 comma minus b, which are this and this. And the length of major segment will be b dash, which is 2b. The ends of minor segment will be a and a dash, which are a comma 0 and minus a comma 0. The length of this minor segment will be a dash, which is 2a. The length of the lattice rectum will be 2a square by b, and eccentricity e will be under root 1 minus a square by b square. Here are they: the length of minor segment, length of lattice rectum, and the eccentricity. These are also the important points which you should remember. Same as the horizontal ellipse, but here x and y axis are different, as the ellipse is not horizontal, it is vertical. We have to identify first if a is greater than b or a is less than b. By doing so, we will get to know if it is an horizontal ellipse or a vertical ellipse, and then we can find any of these terms. Let's do an example on this. Find the eccentricity of ellipse x square by a square plus y square by b square is equal to 1. A is greater than b if the line segment joining the foci subtends a right angle at one of the minor axes. It means that the line segment joining the foci, this ss dash, it subtends a right angle at one of the minor axes. So this one is our minor axis, so it subtends an angle of 90 degree here. So if this is 90 degree, then the minor axis divides it into 45 degree and 45 degree. We are given this ellipse. Here A is greater than B, so it will be a horizontal ellipse. And we have to find the eccentricity. So let's get started. Here we know the angle is 45 degree and this will be right angle triangle because here it will subtend the both x and y axis are perpendicular, so it will be 90 degree. And if we consider this triangle or this triangle, in fact, so tan 45, apply tan 45, we will get AE by B. So tan 45 is 1, so we will get AE is equal to B. Now use this equation. This is for horizontal ellipse. B square is equal to A square in bracket 1 minus E square. This is derived from the equation of eccentricity. Eccentricity is under root 1 minus B square by A square. So squaring both sides and arranging the term, we will get this equation. Then substitute A is equal to B here. On substituting, we get A square E square is equal to A square minus A square E square. So by arranging and solving this, we further get E is equal to 1 by under root 2. So this is our eccentricity. This is the next sum. Find the eccentricity of ellipse x square by A square plus y square by B square is equal to 1, where A is greater than B if minor axis segment forms an equilateral triangle with one of the foci. I want you to try this sum on your own and comment the answer in the comment box. Let's move on to the next question. Next question is, find the eccentricity if the length of lattice rectum of ellipse is 1/3 of the length of major segment. In this question, we have given directly what we have to find and the condition for finding it. So for lattice rectum, we know it is 2b square by a, and it is 1/3 of the length of major segment. Major segment's length is 2a. So by using the equation, we can get 3b square is equal to a square. Now consider the equation. B square is equal to a in bracket 1 minus e square. So it will be b square is equal to 3b square in bracket 1 minus e square. When we substitute a in place of 3b square, or we can substitute other side also. So eccentricity, by solving this equation, we will get under root 2 by 3. So your answer will be under root 2 by 3. Hope you liked today's session. Do consider subscribing our channel and hit that like button if you like my video. Share this with your friends, and thank you for watching.